We have this circuit where two capacitors are in parallel to an inductor. We need to find what is the frequency and peak value of the current flowing through the coil if initially the capacitors were charged to a voltage of V. So in all such circuit problems where these LC oscillations are involved, or even in LCR circuits, so our steps are: first we write the differential equation from KVL, and then we try to get the equation in single variable, and then we solve that equation and put the initial conditions to get our solution. So here let's write the variables first. So let the charges be minus Q1 and Q1 on this one, minus Q2 and Q2 here, I1, I2, and current in coil will be I1 plus I2. So step 1, differential equation. So let's take this loop. So Q1 by C1 is equal to L d I1 plus I2 by dt. And if we talk about this loop, then Q2 by C2 is equal to again L d I1 plus I2 by dt. So let's take one of these two equations. So this gives Q1 by C1 minus L d by dt of I1 plus I2. Now what we need is, we need to get the equation in single variable. So here we have three variables, Q1, I1 and I2. So you can imagine what we are going to do. So I2. So if we differentiate this equation, this and this, what we get is I1 by C1 is equal to I2 by C2. So first we just replace I2 with I1. So this equation will become this. So we got rid of I2, now we need to get rid of I1. So we can see here I1 is minus dq1 by dt. So we put that here and we simplified this, and we have got our equation in single variable, which you can see is the equation of harmonic motion. So Q1 is varying harmonically, and the frequency of this oscillation will be 1 by root L C1 plus C2. Now this is just the value of frequency, first part. Now let's find the second part. So here he is asking the current. So we can get Q1 from this equation by the solution of this equation, and similarly we can find Q2 if we do this whole process for the second loop. So we'll get Q1 and Q2, and then if we differentiate that, we'll get the values of current. So let's do that. So the solution of that equation in charge, that harmonic variation of charge in 1, is Q1 naught cos omega t plus phi. Now initially the capacitor is charged to the maximum, so Q1 is Q1 0 at t is equal to 0. That means phi is equal to 0. So we differentiate this equation and we get I1 is equal to minus Q1 naught omega sine omega t. Now I'm not solving it for the whole thing for the second loop, but if you follow the whole process, you are going to get I2 is equal to minus Q2 naught omega sine omega t. So we need I1 plus I2, so we do that. So that will be this. Now the peak charges on capacitors. So we are given that initially capacitors were charged to a voltage of V. So the peak charges will be C1V and C2V. Omega we already saw, it is 1 upon root L C1 plus C2. So this part represents the maximum current which they were asking. So that's the peak current. So you can see here quite obviously when the current is maximum, here is a sin omega t term and here is cos omega t term. So when current is maximum, charge on the capacitor will be 0 on both the capacitors. So this is the first method, which is the standard way of doing it, but of course we can solve it with a shortcut. So we can see that both these capacitors are in parallel and they are charged with the same voltage, so we can just replace them with an equivalent capacitor. Since they are in parallel, equivalent capacitance will be C1 plus C2, and we know in an LC circuit omega is 1 by LC, so here it will be 1 by root LC equivalent. C equivalent will be C1 plus C2. I max is Q naught omega, where Q naught we are writing as the peak charge on the C equivalent. So Q naught will be C equivalent into V. So again, if you put the value of C equivalent here, that is C1 plus C2, and we write omega as this, we get our answer. So this is a shortcut, but of course we must know how to solve this with the proper equations. All right.